Warm welcome. My name is Adam Hems. I'm one of the leaders of the Houston Azure User Group, along with my co-leader, Kim Vardy. Say hi, Kim. Hi, Kim. So we've been running this for a few years. This is a community event. See a few new faces. I've met some of you, like Hannah. New faces. Yeah, see Monica, right? And Marcos, welcome. For those new faces, we're a community, so this is a place to come and learn from each other and from the speaker. So if you leave here having learned something, then that was a success. I'll ask that question at the end, and maybe we'll learn from each other. Maybe the speaker will learn from us. So that's why we're here. Not a sales pitch. My day job, and actually so is Kim's, is working with Azure all day, every day. So this is a chance really to share our knowledge, learn from one another, and do really, because we're all tech nerds. Tech nerds? Everyone tech nerds in the room? Lots of nodding. There we go. There it is. Yeah, we're all tech nerds. We like to learn this stuff, but also it's nice to meet other people who are also tech nerds and chat about it with different industries and companies and things like that. So that's what we're about here, a place to learn and meet other people, to learn from, and also eat some pizza as well and hang out. So we do that. And so tonight's pizzas, we are sponsored. So the sponsorship varies. Someone has to pay for it. And tonight it's Kodiak who are paying for the food. So thank you, Kodiak. It's appreciated. We like being fed. Otherwise, you have to do it during the day. All right. With that, so tonight, a member of the community. So often have Microsoft folks speaking, which is all good. Or us, but members of the community are some of the best ones. We have a member of the community tonight, Ben, who's going to talk to us about Kubernetes. Ben, I'll hand it to you for introductions and take it away, sir.
Thank you. Okay, I'm all mic'd up here and I'm getting a little bit of feedback already. So you gotta going this way, or maybe I'll just do the.
Just don't speak too loud.
Is that better?
Yeah, let's try that. There we go. Let's try that.
All right.
We can't see any presentation.
Okay, that's okay. So let's get started. I am a Houston native. My name is Ben Ghazi. I have feedback still. Go lower. Go.
Interpretive dance.
Okay. Just ping us, virtual folks, if you can't hear us. All this a little bit. Yeah. Okay, so I've been around Houston building software for almost 25 years. Yeah, I wanted I was asked to speak and I took the opportunity. The disclaimer that I have is this is sort of a description of where I've been and what we've learned. Oh, this is killing me.
How's that, Mike?
Not so nice, but it is booming.
Good.
Can you guys online hear me?
You're on mute. Someone say.
How's that?
Room is. Okay, so the room will pick up your voice.
The room will pick up my voice. How's that?
Well, for us.
Yeah.
Better. Hello, room. Can you pick up my voice for the virtual people?
Yes.
Okay. Okay. Well, I'm over here now, so you can't see me. But yeah, So like I was saying, I spent my career building software. So I came from the app dev side. We were building out servers on rigs and putting our custom apps on, racks on rigs and FTPing things, FTPing files and configs and all those things over, VSAT back in the day. Everybody, yep, everybody's love VSAT. I'm sort of a rig guy. Anyways, grew up a little bit, started getting into the cloud, started getting into bigger and better projects, started getting into, all right, well, the cloud's cool, but it's pretty difficult. And so we got better and better at the time. And then the Kubernetes project happened for me. So that was, probably 7 years ago, 8 years ago. And we built some pretty wild stuff for a major oil and gas company on some pretty early versions of Kubernetes. Failed a lot.
So you learn.
Burned up a lot. And we found a lot of bugs. We found a lot of Kubernetes bugs. We found a lot of Azure bugs. We found a lot of, it's the way it was back then. Things have sort of leveled out and gotten smoother and gotten a little bit easier. And so what we did was we sort of, my co-founder and I, we took these emergent designs out of what we saw was happening with infrastructure and with application development. There's sort of this gap between application developers, project managers, team leads, and the infrastructure guys, the SREs. So that's why I'm not sharing right now. I actually kind of wanted to ask a few questions. How many of you folks are using Kubernetes today? A couple, but very small. How many of you folks are Kubernetes curious? Okay, we got some curious folks. So not a lot of SREs or DevOps people. Are we app devs? Are we project managers, app devs? Okay. That helps a lot. I can tweak this presentation a little bit. So we're not going to talk about the syntax. We're not going to talk about, how AKS works versus other systems. We're going to talk about why Kubernetes is powerful, and it is truly, truly a game changer. That's why it has broad adoption. We're going to talk about the emergent designs in the industry, why Kubernetes came to be, what containers has to offer if we treat them right, and what the heck is a container anyways, and what we should be aware of. Last thing, I will be using my own product to demonstrate some of these things, but it's to show the design, show the concept, right? It's not, this is not a sell. This is just these designs, this way you work with containers, we feel strongly about, right? And so they need to be treated as products. They need to be, shown with a little bit of app dev respect, if you will. Right, so we'll be in the app a little bit, purely just to show you what that concept looks like. So let's get started. Okay, you see it. So this, if you read the brief that I put up on this meetup, this is about teamwork within Kubernetes, which kind of, if anybody knows Kubernetes, will tell you that's an oxymoron. Kubernetes and teamwork is like oil and water. Kubernetes is probably the best place on the planet to run your system and your apps, right? It keeps things healthy. It keeps things resilient. It'll keep things, running no matter what. It'll try and retry again. You can imbue your apps with all kinds of wild things to keep that thing up and running and healthy. From an SRE perspective, site reliability engineer, that's why everybody goes with it, right? It's also probably the worst place on the planet for teams to run apps because it's not collaborative. It's esoteric. It's hard to work with. YAML files, is it repeatable? How do you mess with it? How do you tweak it? What's that, weird incantation I need to get this one working just like that one working? And so can I offer my team a spot in my glorious Kubernetes, garden, or do I have to handhold them throughout the whole process, right? And so that's what we're saying. This concept is really, really important. A little bit of history on Kubernetes. If anybody knows what it is, Google produced this and released it as one of the first open source projects in the Cloud Native Foundation, right? It's open source, but Google had been working on it for probably 10 years before that, with a couple, monikers, Bard is one. So they were really using it for apps like Google Maps and, things that needed high availability. And then it got so big and hard and unwieldy, they were like, let's just give it out to the community because any little bug fix that happens out in the community will happen. So it went out, and back then it was like really crazy. Only the deepest of the deepest knowledge could really use it. And today it's got really broad adoption, but there's still this divide between those that understand it and can use it and those that are just sort of beholden to those that understand it and use it, right? So how do you get into best practices with Kubernetes, and what does that really look like? So I should have asked first, but number one is always security. And so this is the top 5. Sorry, excuse me, let me back up. This is the top 5, and I can do top whatever's, but I actually have 11. So
All good.
we're gonna get as far as we can get with this, but these first 5 are really actually kind of like goals, right? They're sort of must-haves, and they're sort of why you come to Kubernetes, right? So if you're not doing these first 5, it's a good time to start, taking a look at that. So, security like RBAC, role-based authorization, right? Can that person get into that spot and, monkey around with the gears, or can we lock them out? Number 2, we'll talk more in detail in a minute. Number 3, I have, slashed out, adopting GitOps and GitFlow. That was the tool of the day, and now things are kind of progressing forward with more of a generic repeatability by default. Whatever you use needs to be very, very repeatable. And 4 and 5 are really our goals. Our goals are, can I create an environment on demand, right? If my sales team asks me for a new environment to show that customer that we're chasing, is it going to take a week, or is it going to take, a couple seconds? Is it self-service, right? And so that's number 5, which is Kubernetes is a great place to collaborate, but it's really hard because, when the thing breaks, who knows how to fix it? So we really want to start promoting self-service so that we can stay focused on the things that matter, which is keeping my production systems running, right? Any questions on that? Am I going too deep already? Or is that deep enough? Are we?
So by environments on demand, are you including operating systems?
Yes, that's right. So, the question was, environments on demand, are you including operating systems? And so because Kubernetes only works with containers, it already has its operating system. So, you will have Kubernetes gives you the ability to run Windows operating systems right next to Linux, and different node groups. You can define that operating system to the last degree, right? Because inside the container, not out, right? So that's a really good question. The cool thing is, like, you can really abstract it away and just say, hey, look, app developer, or whoever is managing that, maybe it's me, the guy that's, brokering all this stuff. I have to be concerned about this one and only one time. And then from there on else, it's going to travel from every environment the exact same way, right? So you have that really high reliability. Like, yeah, I wrote that server, not OS. I used a particular OS with a particular server inside my container, and I got it just right. Right now that I got it just right, it goes anywhere. It goes to production, goes to another cluster on another place on Azure, right? So self-service is really, really key. Yeah.
So, I mean, you mentioned saying when things break, it's very hard. Are you saying that's when it breaks within Kubernetes, or is it if you don't use Kubernetes?
Yes.
Why? Because we don't know how,
Yes, but
any experience with the Kubernetes. So
do you have experience with Kubernetes?
a little bit, but
Yeah.
it's already hard.
Here's the wild part. Kubernetes is easy to get that first thing working, right? And then you stack a little bit more onto that first thing, and then you do a second thing, and you do a third thing, and then you bring your buddy in, and y'all start working on it together, and you start drifting on the configurations, or things start behaving differently. So the question was for the folks on the virtual side, when I say, are things breaking, do I mean Kubernetes or do I mean things not Kubernetes? I mean Kubernetes, but also I mean both.
Yeah, I thought Kubernetes itself is not to.
So what's the,
Okay.
I'll put it back to you. Like, what are the 5 things that we have needed since the 60s to get an app to run, right? Like IBM, back when they found moth bugs in vacuum tubes, you needed the same 5 things. You needed CPU, you needed memory, you needed ingress, you needed configurations, and you needed replicas, right? So like that hasn't changed. All this technology has been, trying to solve these same 5 things for decades, right? And so, yeah, things break, things get misconfigured, things drift. And I do mean Kubernetes, and I do mean the apps inside Kubernetes, right? So it's sort of a game of whack-a-mole, right? It's like, which level of failure am I at, right? That's why everybody gets afraid of Kubernetes. That's why, segue to the next set of best practices. That's why we do things the way we do things in Kubernetes. There are a set of practices that will keep you from imploding, right? So it'll keep you from having configuration drift, which is a really, really big problem, right? Configuration drift of Kubernetes and configuration drift of your apps running inside of Kubernetes. Those 2 levels are really, really difficult to manage. But if you manage them and you have a very repeatable process, it's a great place to work, right? So that puts me on something to really we should really talk about, which is the real focus in emergent design that we, focus on all day, every day is repeatability and uniformity, right? So if you go back to environments on demand, number 4, that's probably one of my most sought after achievement for all the work I do in the cloud, right? If I can truly have an environment on demand where I can reproduce exactly what's happening in production somewhere else, then I know I've won. Then I know I have reproducibility and uniformity, right? I know that I have all my ducks in a row, right? Because that truly tells me, that's my litmus test of like, okay, well, I can reproduce this environment and everything works as is with a little bit shift on maybe your URLs or your configs, which database you're pointing to. So that's the sort of why I was saying.
And help me out there. So you mean I'm a developer, I wanna, on where we left off with prod, with Kubernetes, I can push a button and now I have test.app.com that is exactly the same prod because I copied.
Yeah, that's the for us, for me personally, and for us, that's the real value of Kubernetes, which is if you go back to number 2, I said I was going to come back to this. There's this thing in Kubernetes called namespaces, right? It is a beautiful design. It allows you to isolate apps running inside of it, right? So if you put 15 apps inside of a namespace, you'll get networking and you'll be able to call things from within the namespace, right? And you can egress into it, ingress into it. Figure things differently than the namespace right next to it, right? So you can have an exact clone of, production next to U8, and you can create a UAT, and I'll show you that in a minute, because of namespace, right? It's a great design, right? So you don't have to rebuild Kubernetes. You don't have to even put all your apps in another new namespace and change a few configurations, right? Point the database off of prod to UAT, right? Is that starting to make sense?
Yeah.
Of like where the failures are happening?
One namespace, the parts within one namespace.
You can, but it's harder, right? So you can, but it's really easy to check. So let me give you an example.
Why would you want to do that?
It is, and that's what I'll show you. So,
Could there be a use case that you want to do that?
I mean that, but you can have service meshes, right? You can have, we're on a best practices conversation. No, it's not best practices. Keep your networking inside of a namespace, right? If you're not ingressing or egressing from that namespace, you really shouldn't chat namespaces. So take, for example, though, here's a dev environment, right? It's got all my things in it. I've got my demo API, my demo front end, whatever it is. These are the service names for a given app, right? So if this app, if I want to go talk to it, let's say this front end needs to talk to, or that's a bad example, but let's say this worker needs to go hit this API inside of Kubernetes. It would literally just say http://API, right? And bang, it gets whatever data it wants, right? Because it lives right beside it, right? And so keeping all your apps consolidated inside of namespaces is a really, really good best practice, right? It's actually probably one of the most important ones after security. We have a question.
You would put all your apps in one namespace in Kubernetes. What about the data that they work on? Would that be in the same namespace or someplace else?
That's another great question. So it's up to you. So there's, there's the good cloud answer, which is, if it's prod, it's probably a managed service, right? If it's not prod, it's dev or QA, you probably can put that database in the cluster and let it live and die together. Managed services are as simple as a URL these days. You're not scripting out things. You can just point to whatever database you have somewhere on Azure. Yeah, and that's another layer of why things fail, right? So I've got a managed service out there. Maybe it's a database, maybe it's a file store, maybe it's, whatever. Did I hit it right? Is it configured right? Is it still running? If you put all that inside of Kubernetes, you can be sure it will be running, right? Which is a really nice thing. So there was a time where everybody would freak you out to not put your database in Kubernetes. Those times are sort of, they're really dying off. It is a perfectly fine practice now with PVCs, persistent volume claims to have high availability stateful services inside of Kubernetes, right? Mongo Atlas makes a lot of money doing that, right? So
I was naming my app as default and service, and then Ingress Nginx as Nginx Ingress as namespace. Then I was reading that document on the Nginx saying, oh, you need to have the same namespace as what your service is. Is that true, or like otherwise it won't be able to connect?
no, it's not.
It's not, okay.
So ingress controllers and ingress, I can touch on that a little bit. It's in the slides here, but it is not true. Your ingress controller will be in its own namespace.
Yeah.
But you've applied an IP address, a static IP address to your cluster.
Yes.
That thing is the big funnel, right? Is if you can reach that IP address from a DNS, then you can funnel in all requests to that ingress controller, and that ingress controller will route traffic to whatever namespace it needs, right?
So that's how you do authentication too?
Authentication to what?
You're authenticating on a different server. How do you do that within the?
Yeah. So I can actually use that. I can show you that as an example. Yeah.
So Ben, could you contrast namespaces with maybe service meshes like Istio? Because that does some of those things.
Yeah, I knew that question was coming. Yeah, so Istio is it's okay. It's a lot of work, and it does secure connections. So it'll do TLSing for you across clusters, which is nice. So it'll help you ingress and TLS things like that across clusters. We left it a while ago, and we got on with nats.io.
Okay, I know that one.
It's sort of like a Kafka Istio baby. And the cool thing is where Kafka stops, Nats keeps going. So you can run Nats on remote machines. So you can run it on your laptop or your phone or even another cluster. So everything can talk and replicate and cache data. But yeah, Istio is fine. I just don't find the use for it. It's actually more trouble than it's worth for most cases. I don't see a whole lot of use cases for jumping conversations from cluster to cluster. Besides having a third party that I got to talk to, it's not much of in my designs usually. Again, I'm a consolidator. I want to put it all in one spot. You know, if I can own it, it should be in the same namespace. So let's go into. So briefly, I'm just going to touch on these. Here is why Kubernetes is so rad. And I'm not going to get detail on these, but it's because of these things that are capable that are not found anywhere else, right? So probes for knowing if your app is running, right? Auto scaling with horizontal scale. It's like an accordion. So you can have replicas fire up based off of how much memory and CPU is needed or being used, right? So you've got this ability. You can basically treat yourself like Google or Facebook, right? You can say, well, look, you know, if I get a burst on, you know, if I've got e-commerce and I get a burst of work because my Shopify took off, I can sleep at night because if I hit over, you know, 70% CPU, I know that I'm going to get another copy of that API over and over and over again, right? Until it finally dies down, and then Kubernetes just throws them out for me, right? It manages all that all at real time, all at runtime, right? So you can really tune that thing up to be a total workhorse and also save you money, right? The ingress piece, we'll talk about that in a minute. And for anybody that uses clusters, doesn't sound like you might know, but most people, if this were more of a DevOps crowd, don't ever upgrade your cluster. Don't do it. You're looking for a hellish weekend. You can't usually back them out, right? So once you go up to the version and your app broke, what do? Right? Typically speaking, and there are always exceptions in software, we just tell people, stand up another cluster of the new version and migrate your system over to that new cluster.
It's the version of Kubernetes.
The version of Kubernetes, sorry, I should be more clear. So when you upgrade Kubernetes from 1.2 to 1.3, there is very likely to be a breaking change, right? And it's going to break your production app, and it's going to be some weird esoteric thing that GPT probably doesn't even understand, right? So
There'll be some angry people on
Don't do
Reddit
it.
talking about it.
don't do it. So everybody knows what 4 nines is, right? So like 99.99% uptime. For the year, that gives you about 56 minutes of downtime, right? If you upgrade your clusters as they sit, we'll blow out 99.99 real fast. So yeah, you make, if you did your job right and you got environments on demand and you got uniformity and repeatability, if you got this piece 4 and 5, then doing the second piece or number 9 should be as simple as, right? You should be able to do dark deployments, right? Dark deployments is saying my app runs over here on these URLs, but I'm sneaky over here on these other URLs, so where I can test out a thing in production, point it to the production database, and I can smoke test stuff, and I can maybe break stuff, and I can upgrade stuff, and I can get my house in order, not affect production. And then when I'm ready, you know, at the DNS level or at the gateway level, I can say, okay, now that dark thing is nice and clean, I can just move my URLs over, and all of a sudden, you know, I don't have a 4 nines problem, right? Because if I do, and things start getting flaky, I've got my blue backing me up, right? I can always switch back to blue if I'm going to green. That's a critical piece right there. Like, don't ever upgrade your production systems, especially Kubernetes.
Another use case here is clients that maybe run a SaaS app, but then they have special clients that are very demanding. Not that we have any of those here in town, but they say, sorry, we only do on-prem, or my country doesn't allow it to be hosted in the United States. Then you push a button and your latest SaaS release propagates out to all these private environments so that they can run their own copy of your, what would otherwise be a very challenging SaaS to on-prem migration.
That's right. Good point. So we'll pause on 8. We'll come back to that. 10 and exclamation mark. So 10 is getting more into sort of the SRE role, which is like, look, the guts of Kubernetes is not fun, nor should we really care about it, right? It's not the app. It's just the thing that runs our apps. So we shouldn't pride ourselves on having some esoteric system called Kubernetes running our apps. We should be priding ourselves in how much can I milk out of this system for the cheapest amount of money that I can give Azure, right? Can I truly squeeze that thing? Right? It's called APM, Application Performance Monitoring and Metrics, right? So I can build with Kubernetes because you actually have metrics coming out. It spews out metrics, right? You can get Prometheus and Grafana, and you can watch all your trends, and you can watch when things spike, and you can see these points of failure, and you can build a plan, and you can estimate your costs so that you can have a reliable, smooth billing with extremely high uptime, right? So that piece right there is the part that is fun, right? That's the part that's like, you know, Kubernetes can be very, very frustrating, but once you get to number 10, you're starting to really have fun and playing with the knobs and gears, and you can see your work product produced for your business. All right, and 11 here truly is it's so unspoken in the industry. I can't tell you how many places I've been and things that we've seen where, you know, they have dev working on Azure App Services, they've got QA working on serverless, they've got, you know, production running on Kubernetes. None of it is anywhere close to uniform or repeatable, right? Even if it's all in Kubernetes, people just kind of natively treat lower environments like crap. You know, we're all too busy, right? It's how it goes. But you really shouldn't. You really should treat your lower environments exactly like production, except performance differences, right? Except a database change, except a volume change, right? It should feel like production, right? So that you can go to production and be like, yeah, man, I've been running this thing in a, you know, production clone all week. It should be fine. And it is, right? But when you don't do that and you're over provisioned or under provisioned or you're configured differently, you will guarantee yourself a bad day.
So would you have all production operations duplicated in dev, so you can also check the load, how it handles the loads and stuff, or what?
Maybe. Yeah. Yes and no. Yeah, we do. So we have snapshots, right? So we make sure that every time we do a deployment, we take a snapshot of our manifest of container, right? And we call that a system version or a version of the product, right? And so when things are running, piss poor in dev, we'll actually tag that snapshot as like, this is broken, or here's the reason why it's wrong, right? High collaboration, making sure we're all chatting about it, is really important to us. So yeah, you should have dev, your dev environment truly operating. And you can even do it on your laptop. Like you can get Kubernetes running on your laptop. You're gonna have resource constraints, obviously, because you can put a production version of your system running on your laptop. Develop there, right? Make sure that, yeah, when you're developing it, it behaves differently, right? So HPA is a perfect example. Horizontal pod autoscaler. HPAs are almost never used on lower environments, right? And so you get this choking event happening. Like, why don't my APIs respond? It must be a bug. Let me go spend 5 hours looking for the bug in my API code. When really it was choking on resource constraints. But in production, it works fine. Well, why is that? These little mystical, mysterious things that, well, it works down here or it doesn't work down here, and I have a completely different, thing happening in production. That's what we're trying to avoid, right? So like, if you can make it exactly like production, except it doesn't go to that database, then you're winning. Did I answer your question? Not really.
I'm really suggesting that you duplicate the production environment before you take your new thing and put it in production, just to make sure you won't have problems with volume and things like that.
I agree with that more. That's exactly right. Smoke testing, put it in a dark environment. You don't have to call it dev, but you're going to call it something or you ship it out. So that's where AKS really comes in and starts shining, right? If you're using Kubernetes on Azure, you can just say, hey, look, give me a max, like I want to set a max node count of, let's say 10, right? And you turn on auto scaling. Auto provision those nodes for you when it needs it, right? So all of Kubernetes is a big schedule, promissory architecture, right? So, all right, well, you asked me to go put all these apps on, on a new namespace. I don't have enough room here on this node. I'm going to go ahead and pick up a new node, put the apps, half the apps over there, half the apps over there, right? It'll also do math on it's called quality of service, right? So when it comes time to have your app really, really performant, you can twist the knobs a little bit on, yeah, I need the APIs to be super performant. My front end doesn't need hardly anything. This work over here is a hog. So make sure that when we get pressure on these nodes, on these VMs underneath us, make sure that my worker doesn't fail, right? Fail my APIs first, right? Which is also why Kubernetes is hard.
So if the dev parts and our QA parts and the production parts, they all live together in the same cluster, when you deploy into dev, will that affect, I mean, if you have a wrong configuration, what happens?
That's the lovely part of namespaces, right? So
I see.
everything is scoped
So
to a
it's a good
namespace.
practice, but
It is a great practice. Now, it's a better practice to put production on a different cluster.
different, okay.
Right?
At least you can
But
combine
if you're
QA.
a small, system, internal apps, whatever, yeah, just put it all on,
The same
put it all in one cluster, auto scale that thing, let that thing auto scale up when it needs it. Because all your configurations, so. Here, I'll show you.
Maybe different node pool, same cluster.
Could be. Totally up to you, right? So, this is a perfectly fine example. So we have dev here on demo Azure dev test, right? That's a cluster. And we also have, UAT. Look, on the same cluster. We've got QA on the same cluster. We've got production though on a completely separate cluster, right? And then another production on another cloud, to be exact. But this is how we treat namespaces, right? So each one of these is a namespace, and I put different versions of my app or apps in this namespace, right? And I configured them different. Right? Some of these guys are going to go to, a node A, right? Maybe that's an Ubuntu node pool, right? Some of these guys might go to a Windows node. That's advanced stuff. You probably don't need to know it.
Yeah.
Really, honestly, you have one node pool with plenty of space and dump them all in there. It'll be fine, right? Because all of these things are very, very tightly scoped. Right, so when I say, well, I need to change the configurations for QA, I go look at my front end here. Take this as an example. I need to change my front end configuration to be demo. I can change this configuration and only deploy out that change to that namespace. I'm not going to affect anything else over here, right? So that's how Kubernetes works. You're just telling this one spot, hey, get my configuration out for this one spot. Does that make sense?
Yeah.
Okay, so last bit, we have URLs. It's called ingress, right? Ingress is how we talk to the world, or how the world talks to us, quite honestly. And so you asked, well, the ingress controller told me I need to be in the same namespace. Right? That's not really how Kubernetes works, right? So this is where repeatability and uniformity really, really, really matter, right? You should, and it doesn't matter how you do it, but take, for example, we have this domain name called BuyByBox, right? That's our business. The BuyByBox needs, its app running. But we also need some subdomains for dark deployments and internal work for dev and lower environments. It is crucial that you see this here, that service dot blah, 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 this here. That's a canonical strategy, right? So you basically say, it doesn't matter how you do this, but you should be doing this, which is saying, I don't care how many apps I have in Author, right? If it needs ingress, it will follow this strategy canonically. It has to, right? This is my Lord for this guy, right? And all these things get developed. So these URLs become very, very uniform and everybody knows where they are, right? But look, these URLs for dev are completely different than the URLs for production, right? So to your question, yeah, you don't need every single URL is going to that same cluster, but that ingress controller is basically saying, hey, is there a registered ingress for this path?
Yeah.
Right? And if there is, it'll route it for you. Right? People get in a lot of trouble by writing ingresses and then forgetting about them and then forgetting to tell the developer, or the developer says, well, it's /API/this. And you get drift off of these ingresses versus what's in the app. That's why a lot of dev teams have trouble keeping the train on the track.
They have standards, but they're in everybody's heads or maybe even written down, but they're not in code.
Definitely needs to follow some standard way throughout the organization. That's really important. Okay, did I bore you enough? You want some more boredom?
This is all good stuff. Keep going.
Good stuff.
Done it.
So Ben, I'm just real quick, I know there's a bunch of consultants in the room trying to help customers get to Azure. You showed something I want to highlight just because you probably flew by back in your environment there. One of your environments is in AWS. It's in some other unnamed cloud. And if you want to migrate them to Azure, you just drag it.
That's right. So, so let's back up a bit because talk about our goals. Let's talk about why Kubernetes and containers anyways, right? Containers were built for what? For uniformity, portability. Anything inside of that container is none of my business. It's not. I'm hands off. I take a container and I put it over here. It should operate just like when I put it over here. That was the idea 15 years ago, right? Just never really came to fruition, right? But the idea is always the same. It's like we said back in the 60s, we need 5 things to get anything running, right? If you take that and really crunch that down into what does the world look like when containers truly are portable? You can provision anywhere, you can ingress anywhere. It's all the same, right? You have these rules of the road that you can now abide by for everybody, right? So, what's that saying where, what was that author that said, they have more freedom with more discipline, right? The more disciplined you treat a thing, the more free your mind is, right? So like, if you schedule yourself, time to get all the things done, you're left with way more time. Say it's sort of the same thing with containers. If you really stick to the rules of the road of how to do it repeatedly and uniformly, build your oyster, right? So now you can treat this cloud like that cloud, and this Kubernetes like that Kubernetes, like that Kubernetes. Because I can tell you, just going from one Kubernetes to the next is scary. It's hard. This version doesn't operate like that version. These node types provision and spin up different. There's all kinds of little, esoteric things. But if you stick to best practices and you really keep Kubernetes free from third parties, right? So like when you use K8s, K8s is the short for Kubernetes, K8s, K8s. When you use K8s, there's a lot in the industry, including, this company, that want to sell you on something, right? But it's some level of overhead or third-party esoteric thing now that you have to hope that it works, right? The nice thing about Kubernetes is it already has an API. It already has the objects that it needs, right? So like, make sure that whatever tool you're using produces raw, straight up Kubernetes objects, right? And so when you do that, Kubernetes will handle that, manage that state for you. It's in YAML, which kind of sucks, but it's there anyways. So that's sort of your get out of jail free card to where you can say, well, look, I got my Kubernetes objects here and I can use them elsewhere, maybe with code tweaks. But when you get into third parties that they'll jump into your cluster and they'll unfold things sort of in a non-standard way, that's when people get real tripped out on, you know, how these things work. So you sort of black boxed yourself. That's when you start getting into treating clusters like pets, right? So like you got to feed it, you got to water it, you got to make sure that the nodes are right, make sure that third-party tools configured right. It's a dance. And what we're saying is, no, it really needs to be treated like if I shoot it in the head, I can go do it again tomorrow just fine. Right.
Question?
Yeah.
May not be a good one, but guilty of it now.
Yeah.
72. You go back to something a year later that you haven't used. Is it pretty good at self-documenting that you can pick up the pieces? You can comfortably sell it to management? What do you think?
No. I mean, no. That's my quick short answer is a year later, you have drifted so far off from the initial intent of that thing. Unless you have it in code somewhere that you can draw up, which is even that I would say is like good luck. No, you Kubernetes is good for managing its current state. It doesn't go back in history. It doesn't do auditing for you.
You can't just take something from the past that you did.
No,
Look at it.
it merely tells you what is running.
Excuse me.
No, you're fine. A good question.
So you mentioned about upgrading Kubernetes. Now, when you upgrade, what generally can break? Is that like your API version you mentioned V1?
Every day.
I still see that some of those versions are still V1.
Yeah, so-
V1.
There are, okay, so the big three,
Sir, do you?
the big three cloud companies, this one included, want to kick you off the old versions.
Yeah.
Because they know that, well, for one, it costs them money. And two, they know that the longer that you keep that old cluster around, the more chance of failure you're gonna have. Right, so like you actually, this cloud company is different, but the other one that rhymes with AWS will charge you for old versions, right? So like
A much higher rate.
the moment you're out of their window of support, you start paying 30, 40, 50% more for an old busted club. Right?
Yeah.
So like, they want you to get off of it. They need you to get off of it. You should be getting off it. Everybody just sitting there like, it's hard. It's too scary. I don't know how to do it. So yeah, you really need to be, that's why blue greening and creating the new cluster, testing things out really
So
matters.
will that change all these YAMLs then in that case, in the sense
Yeah.
like the version, like the API version will change to
Yes, they will.
different with the.
Right. That's why YAML sucks.
Yeah.
Well, the YAML should still work with a new version.
You would think.
Yeah.
No?
That's the hope.
Yeah. you would think that whoever designed the next version would be a backwards compatible thinker.
When you have 1,000 variables matrixed with dependencies.
Yeah, I mean, it looks hard. And there are some, so they move fast, they move by community, and they move as smoothly as they can. But it is an open source project. And so they are sort of listening to the community, and the community has the voice, which is like, move faster. I don't care if you break shit. I want that thing fixed or that feature out, right? And so, if it breaks, it breaks. I'll create a new one. And that's why. So guys, this is all pretty sophisticated stuff, right? So like, Kubernetes is no joke. It can be very, very simple. But there's a whole subsector of our industry just focused on this business, right? And there are entire teams working on things like you're seeing on the screen, right? That are fully tasked out, fully tasked out, right? Like they are overbooked on how do we keep 4 nines and move clusters and upgrade and keep my devs happy and keep my URLs working, keep my CTO happy. Like, how do I get that demo environment so we can go sell another thing? Yeah, not a good answer. The URLs are going to, or the YAMLs are going to change and it will break. Not always. Any other questions? Yeah, now we're talking best practices there. Yes. Okay, so somebody, Daniel, is it? Good to meet you. So Daniel just talked about a real big void thing, right? Geographic redundancy, geoproximity. So what he's asking for is, hey, can I have a couple clusters in Europe, a couple clusters in Australia, a couple clusters in North America, South America, and I all running the same version. And then when somebody hits my website, it finds that closest cluster. Right? Question? Okay, so this is the blue-green that we're talking about, right? So funny you bring this up. We have a customer that is doing this now. They're putting 2 clusters on 7 continents and proximity routing, and they're using always using 1 cluster as a deal. And so it's great practice. That's when tools really, really matter, right? So tools that can really do blue greening well and manage your app service stats, that really matters, right? Gateways look like, and are you on Azure? Front door, right? And Azure API gateways are traffic manager, express routing.
No, that's VNetting. Oh, yeah. But I was going to say, right, what about Fleet Manager? So Fleet Manager will manage your AKS clusters and do some of the deployment work.
Yeah.
Across regions.
Yep. So deployment work. So Kubernetes, Microsoft's really good at provisioning the things. The rub is managing the internal workings of the clusters, right? So yeah, for sure, it's a great tool. Tools matter in a big way here. I always say a couple things to think about. Keeping your CI/CD as anemic as possible, right? So when I say anemic, I don't mean it in a bad way. Scripting things inside of CI/CD is bad for you, right? And so if you can, the least amount of lines that you can have to achieve this, the better, right? tools for routing, and tools for configuring, right? So making sure that you can configure, let's say you're in, 2 clusters in North America. You need to be able to always have one cluster, one version behind or ahead, right? And then be able to canary your customers, right? Or canary somebody. Canary just means I'm going to put a couple of my customers or a couple of my users on the new version and just let them I'll watch all the metrics, right? Observability really matters big time there. But yeah, there are really good tools for that. Keeping your blue-green strategy just dead to rights is your key right there, especially with configuration. Did I answer your question? Yeah, that's all. That was a fun one. You doing that now?
Yeah.
Awesome. Yeah. That's very, very cool. So fleet deployments is a whole, talk to me afterwards. Let's talk, because like I'm a big nerd for fleet deployments. It's hard. It's not fun. But yeah, it's a good. What does it look like right now? Like, how are y'all? What are y'all working on?
So what we're doing is we're taking each geographic region and pairing it with Microsoft's, each like geographic location has a paired region, right? So, I think US Central is East 2 in Virginia, right?
Yep.
So, deploying, active clusters there. So, we'll have 3 pods running in Central and then 3 over in East 2, right?
Okay. And how are you routing?
We're not using the like Azure tool set for that.
Yeah.
We're managing the ingress ourselves. For
Okay.
that one. And then doing the same thing over here.
You have a gateway in front of it?
Yeah.
Yeah.
Are you using Fleet Manager at all to do it?
But that's why I'm here.
So have you gone through a cluster upgrade yet?
Yes,
How'd that go?
it was fine.
You upgraded in place?
Yeah.
Okay. I want to sell you out of that. I think we can automate that. Yeah, it's, and this is in production.
Yes,
Awesome.
Yeah.
That's great. Fun piece of work.
but yeah, just kind of getting the best practices of identifying the geographic paired regions and setting applications up to be active across regions. That has its own challenges, right? Because you've got a whole stack of dependencies
Yeah.
below what we're talking about, right? For all the like persistence layer for databases,
Yeah.
Confluent and all that kind of stuff, right? So that comes with its own challenge. Like what does the geographic redundancy mean for those resources?
Mhm.
That's its own question, right?
That is this. So for everybody that didn't follow all that, this is geographic redundancy. So what Daniel's talking about is blast radius, right? So what happens when, Azure has an outage or AWS has an outage or, we just can't figure it out.
Or the network provider in that part of the country.
You're right. Yeah, geopolitical issues. It is such a good practice, and I'll say this with a lot of emphasis, to try if you are at, or if your business is at that point where you cannot have downtime and you're looking for 4 nines, getting your footprint on both or 3 clouds is great practice. It's incredibly difficult, but it is great practice. And being able to show that to your customers, being able to show that to the business really provides a ton of value for them. So this is essentially that, right? We're saying, hey, I've got all my apps here at some particular version, And I've got the old version running on Azure. I got my new version running on AWS, and I can start, migrating those requests off of it in case of an event. Yeah, it's really powerful stuff. Any other questions?
Yes, I used Docker for many years. Would I put Docker containers inside a Kubernetes cluster or
Yes,
what?
you would. Yep, so Kubernetes doesn't care who built it. It just cares that it was built a particular way, right? So Docker will give you, if you're on a Mac, you got to use build X, and you got to say, hey, build me with this architecture. But if you build with a Linux, AMD 64 architecture, that thing will pretty much go anywhere, right?
You can do ARM too.
Yeah, you can do ARM. ARM is great for AKS.
Yeah.
That thing will go pretty much anywhere. You will run into trouble with Mac machines, stupid one, that will build you the wrong architecture. And so Kubernetes, again, is a promissory system. So it'll go try to put it on that underlying resource. It'll just keep failing, right? And a little known fact, it'll report out a 401 to you, when quite honestly, it's not. Whatever. But yeah, a container is a container is a container, right? Until it's not.
I mean, there are different types of clusters too, like there's like Minikube or Cubadium.
Yeah.
So
What's AKS is running microcase, isn't it?
I do not know.
I think it is. I
Don't
think it's
know.
running. I think it's running. Yeah, there's different versions.
what do you?
We recommend microcase. So if you're gonna run on your laptop, run microcase. Yeah, it's good. It's as close to the cloud as you'll feel.
Is it? Okay. So that comes with the Docker desktop as well.
Does it?
I don't know.
I think they did for a while, and they got it started to feel like bloatware, and I think they might have taken it out.
And then it doesn't give an option. I mean,
Yeah, if I were Docker, I wouldn't have anything to do with Kubernetes, but I think the decision is there politically. Anybody else have any questions, any thoughts? Daniel had probably the best cool use case. Anybody else using cool use cases? Big needs, fun stories? Has anybody crashed production?
And willing to admit.
Nobody's crashed production?
And willing to admit.
That's right, I sure have. This week I did. Yeah, no, it's a scary deal.
Share your experience and what do you do to get back on track?
I can share my, I mean, I can, like,
I mean, like,
so my experiences are the product that I built. So like, we crashed production. It's not that big a deal because we got ability to roll back quickly, right? But
that's what I want to hear.
it's, okay, so,
Things happen.
let's talk about blast radius, right? And remediation. How do you clean up your spill, right? When you don't have, so everything that we do, we try to make immutable, right? Like that's the goal. Repeatability, uniformity, immutability, right? If it can be reconstructed, you can kind of give yourself a little bit of leeway. What you're touching on is like GitOps and, having some sort of auditable, traceable thing to go back in branches and say, okay, it was this thing, maybe it's that. I have personal animus and hatred towards GitOps, and it's reflected in things I do day to day. But it's the tool that was available at the time. I think there's the industry is really sort of reckoning with that right now, which is like, who knows how to, raise your hand if you've ever done a rollback. Right? So like, was it miserable? Or do you usually roll forward? Right? Can you roll back 13 services? Can you roll back 50 services? Can you roll back that thing 2 weeks ago? Probably can.
Roll back 14 sites globally.
Right, how do you, yeah, like,
You can.
most people in the industry are rolling forward. They're saying, oh shit, something broke. Shove it in, see if that works, right? Rollbacks are major added value to the industry that most people, it sounds like you're doing it just fine, but it is really crucially important. And we see people that are terrible at it, right? And so like,
So what's best practice for BCDR, business continuity and recovery, disaster recovery?
depends on the business, right? So like, for me, it's exactly what you see on the screen, right? You need to be able to say, I have traceability. I know exactly which version it is. I can roll back my whole system. I can roll back a part of my system. I can roll back my configurations, right? That has to be baked into your process. If it's
And
not,
he's holding back because he's not supposed to be selling, but he
Right.
has a screen that does exactly this.
yeah, no, but so when I first started this conversation tonight, I said, these emergent properties and designs are because I have 25 years of boning it up, right? And I need these tools to work for me so my product dev team can be safe, right? And so it's not just the version of the container that's running out there. It's the configurations that's running out there. It's the secrets, it's the HPAs, it's the labels, it's the annotations, it's the ingressing. It's all of it, right? All 5 things need to be auditable and traceable and rollbackable, right? So like, if you don't have that, you should be codifying that somewhere, right? Inside of a code repo is where most people do it, right? And that's a miserable time because
So now is sit there and look at your deployment logs and your GitOps scripts and try and figure out what went wrong. Whereas, wouldn't it be wonderful if there was a snapshot of every deployment we've done and you could say, which one was the last one that we know worked? Roll back to that one right now. And 8 seconds later, you're there.
well, that's the blue green too, right? It's like you I don't ever when I say I broke production, I usually mean dark deployments because we don't ever usually go to production much. And we just flip-flop, blue greens.
So are you saying that in Kubernetes, it keeps those snapshots?
No, it doesn't. So that's the problem with Kubernetes is it's just current state, right? So tell me how are you guys doing? Like, I would love to hear.
I mean, is that, I don't know whether it's a good practice, but if we had to roll back, we will just look it up in the GitHub and see what.
Yeah, look back what? You're
um,
gonna look up the app, you're gonna look up the Kubernetes version, you're gonna look up the configurations, you're gonna look up.
The check-ins.
Yeah, but what are you looking for? Right?
Um,
So like, how do you know what's broken?
I mean,
Nice state config.
That's
Right.
It's good probability, but not necessarily.
Exactly. So like,
I mean,
you're
It's all
actually mentioning
credentials.
this. You bring up a good point. So observability, guys,
I mean,
Guys, without-
based on the law.
without observability, this is all for naught. If you can't see what's happening inside your systems, you're boned. You're never going anywhere, right?
I mean, so based on the log, we will know what is causing this problem. And then we know what has been checked in, where we are.
It's ticking.
And then we go back and see, oh, okay,
Right.
get that version out and then deploy with that version into the production, and that should work. I mean, that's how.
So you did that and then it still isn't working. What's your next thing?
This is where I deploy.
That's where I disagree. I think I think things should be way more deterministic than that. Right? So like,
Well,
it's simple data. We should just have the data.
it's way too much data to read a human being.
Exactly. So what if you had a tool that could do
Yeah.
that?
No, I mean, you know, again, the 5 things, right? This thing, that it comes down to 5 things: memory, CPU, cassettes, configuration, right? And your app. It falls somewhere in there, right? It might be esoteric and weird, but if you design your delivery systems to be immutable and deterministic, it's mechanical. The machinery, the gears aren't going to get, you know, gummed up if it's machinery, right? If it's a human writing YAML, that's, you know, cruising for a bruising. If it's cursor writing YAML, cruising even harder, right? So how do you roll back? How do you have, like, back to your question, like, I'll ask you, like, what is, get this thing, I'm gonna show you. That's good, Daniel, though. So when this happens, this actually was from a couple months ago.
Are you trying to get the?
Yeah, so when this happens, no, but this is the feared of all fears, right? Ah, what happened? What is the first thing that we do when we see this? Observability. Right? Go find out what happened. Root cause. What next? All right, so it was a configuration issue.
Oh my God, what happened? Look at this is the question, this is resort, but what happened?
But I mean, you felt your temperature raised right there. Right?
This
oh my
is
God, everything's
Downdetector.com.
This is where, as an infrastructure person, I say the phrase that all of you hate me for
I told you so.
is in your change management request, you had a rollback, execute your rollback.
So step 2 of this is, step 1 is wrong. It's not observability. Step 1 is what? Glue back over. You go to your safe one. You move your URLs back to your safe one, the one that you know. And then you bring this up in a dark environment and you go fix it. Right? That's your 4 nines answer. Never have that guy. You never have this guy's DR sitting right next to you.
Never without a net.
I want to challenge this. Need this company.
Right, canaries, right? Exactly. So load testing, performance testing, canarying, all the things prior to that. I got one customer that they do PRs after they go to production. Think about that for a second.
Why is that?
Why is that? Why would you do a PR after you went to prod? So as an app developer, you now own it. You own it in prod. Hey, we're running Kubernetes. It will run fine. Design it first. Think about it. Don't write code for me. Get it done right. Put it to production, and then we'll talk about it. Pretty interesting. I don't have the cojones to do it. It's just, it's too much for me. But it's pretty wild, right? Kubernetes allows you to do that. Because they have the ability to fail safe that. Like, okay, well, if it fails, we'll move out of it because it's immutable. Kubernetes is really good at that. Okay, so another point, to your point, and Daniel knows what I'm talking about, where I'm going here, but this number 6, that one's huge. It's So the problem with Kubernetes is it's so hard to get to number 6 that nobody gets to number 6. And number 6 is probably the best reason why you should be at Kubernetes, right? Pros. Is my app running before it goes into rotation? So let's imagine you've got 1 million requests coming in, streaming into this namespace, streaming into your APIs, 1 million requests, a minute.
Fire hose.
Just flooding. And you need more replicas now. You need more APIs running. You need the fire hose is on. You need a bigger hose, right? The fire is running. Kubernetes, if you tell Kubernetes, hey, I've got an API here that will spit out a 200 if you go ask it for its health. Until it spits out a 200, do not put it in rotation. Don't let it have any requests. Just let it sit aside until it gets healthy, right? So you can do database checks. You can check your volume stores. You can check, your memory health. You can check anything you want because the developer writes that, right? The application developer who owns the server writes that. And then finally, all the checks, check can be a mile long. All the checks go green, Kubernetes puts it in rotation. And all of a sudden, that million requests just got a new API, just got another API. And so when something goes wrong, and let's say a node, dies off and you get evicted, right? Evictions are, something goes wrong, that will save you, right? I'm sure you got pros on all your things.
The application that's going up has to have a system health.
100%, right? So, the unfortunate part about Kubernetes is people get tied around the axle before they get there, right? And that's one of those pieces where it saves, to your question, it saves you before you get failing, right? If it keeps failing, well, Kubernetes is just not going to put it in rotation. That makes sense?
Are those health checks provided by Kubernetes itself, or we have to, app developers would have?
You need to define what a healthy API looks like, right? And then you say, hey, Kubernetes, go to this URL, API/health. And if you get a 200 out of it, or if you get a whatever out of it,
It's good.
it's ready to go, right? And then Kubernetes will schedule it, put it in rotation, and spawn that thing up. And it's really, really awesome when you see it.
And you got the other way too. If one of them stops giving a 200, then
Time to live, right? So,
how do you go, right?
so, thanks for that. That's a big one. These computers are binary. They're digital, and yet they have health. It's wild. It's weird. Things will die. Things will just stop working. There will be no logs of it stopping working. It will just get rot, and it just won't work. If you put a health on it and you say, well, hey, look, the time to live on this thing is, we do 24 hours. Everything in our clusters always die before 24 hours, right? So all those pods that we're running, if it has hit unhealthy, Kubernetes will kick it out, kill it, slay it. No, spawn up a brand new fresh baby pod with all the cool new things or same things, right? That's how you keep that flow. It's the more you use these tools, the more you kind of see it's sort of a creature, it's got configuration, sort of the cerebral brain part. There's circulation, there's muscle to it. It's wild. And you got to truly treat it like a being sometimes.
I like to build on the liveness and readiness approach one. So one challenge I've seen is making sure that the developers actually put those in, right? In AKS, it supports Azure policy, and you can create a policy that requires those, which means that a deployment with those missing will actually fail based upon policy, not even
didn't know that.
before it even gets to Kubernetes. Policy will kill it.
That's fantastic. I like that a lot.
And also,
EKS doesn't have that, just so you know.
and also Microsoft provides a lot of cool tools. I mean, we have some things that actually puts everything on the dashboard and shows all the plots of what is working, how is everything, health, everything, like
Yep. It's,
alerts. If something goes bad, then quickly you will get an alert. Hey, something is going on here.
Yeah, you can drown in it too. You know, if you get Datadog rolling, you get Elk Stack going, you get, you know, you start streaming out too much, you can drown in it. So, you know, we sort of, we take the minimalist approach with that kind of stuff to where like, we really don't store logs. We stream them out, but we don't store them, so we don't have to pay for all that. Because you only need them when something actually fails, right? Yeah, it's, I know a very large trading platform spends 25 million on just their Splunk bill.
Who is that?
Splunk is, I can't tell you. Yeah, it's wild. And they're like, yeah, it's okay, it's worth it. We've got it all auditable. I'm like, really? 25 million? Like, okay.
Well, when I was a developer, I hated the word policy because it meant that somebody was trying to stop me from doing my job.
Doing your job wrong.
I think you might have a reputation, right?
So that paradigm right there, you know, we talk about collaboration. This is a sort of an infrastructure and app dev conversation that we're having. That paradigm of developer versus ops people it will never end.
For sure.
I've been on both sides of the fence, and I tell you, in my ripe old age, I will tell you as an app developer to go pound sand. You know? Like, I don't have any patience anymore for app developers that want to cowboy code for me. You know? It's like, these are the rules of the road, these are the policies. If you can't fit into it, you know, then this isn't going to work out. Because it's that dangerous. It's that, you know, I'm not going to be the one telling my customers it's not working, you know.
Because of a bug in raised code.
That's right.
Just remember, app developers are evil. It's just a simple fact of life.
App developers are trying to kill us all.
I think we just found our next trade show, trade t-shirts. We could have two sets. One app devs are evil, one DevOps is evil.
You can make a fortune doing that.
Thank you guys for coming. Any other questions, any other comments, anything you want to chat about?
I got one more. So serverless clusters are the way to go. PVCs, don't want those. Just because we can, they're evil. We don't have those. Serverless is it. All storage should be outside the cluster. Your thoughts?
For production, yes.
For everything. Because the production needs to be the same as the lower.
Oh, he's throwing it back at you.
Someone was paying attention.
Absolutely right.
He's paying attention.
Someone was awake.
Student becomes master.
Mm.
Yeah, no, serverless is wild. I haven't played with it enough.
Okay.
I really want to.
Well, I'm just saying it's philosophy. Philosophically, we have serverless Kubernetes clusters all the time. Just we never use PVCs for reasons.
Sure.
As a philosophy, even though we can.
Well, how you just use file stores?
So you'd use the appropriate data store for the app, right?
Got it.
Whatever you need.
Sure.
MongoDB, a file store.
I like that.
Messaging, whatever the app needs, It's outside the cluster. You pick the right Azure service. That's it. That's the rule.
What about stateful?
Not a thing. Don't have that. State
Never do stateful.
is right. That's the philosophy I'm throwing out.
Wait, so I have to rewrite my app?
Your app is stateful? What the hell?
Just checking.
Well, yes, if your app is garbage, then just rewrite it.
Yeah, so you can have state, it's just not on the
Somewhere else.
cluster.
Yeah.
It's not on the cluster.
That's right.
Don't write that
It's in the
locally,
database.
no PVCs.
No, so that was a big inflection point, 4 or 5 years ago? Everybody was like, yeah, but how do you do stateful in the cluster? It's like, dude, you don't.
It's compute. It's,
Um,
state should be in the database.
everything that you just said, I
Okay, don't argue
Agree
with.
with.
All right, okay. It's all good.
PVCs happen all the time,
Yeah, I mean, they're there. Yeah, but
you know? I do like having the database, like, for lower environments, we'll put the database in the cluster.
yeah,
Um,
SQL Server on a container.
Yep.
You can.
And so we store out.
And then tie that.
Because, so, you know, one thing that you should be mindful of, the burn. Kubernetes will burn, it'll just, everything's running all the time.
Yeah, that's the problem.
Well, not really. Just turn that shit off. So you turn off your lower environments, nice on weekends, right? And you get auto-scaled clusters that will remove nodes when you remove pods, right? And then you shrink your footprint. Give less to Microsoft, but they're making plenty, it'll be fine. You necessarily should be using it as a stateless system. Especially don't put production state in your cluster.
So your SQL points to what in?
They can point to a volume source somewhere,
Volume
right?
source.
You can volume out to whatever you want. And you can just tell Kubernetes about it. Tell your app about it.
And it can be environment dependent and go where
Oh, yeah.
point, where it needs to point.
Everything's configured environment dependent still.
Good for an essay-like question. Where do you think things are gonna be 5 years from now? And what do you think the characteristics are of the key players who are gonna be successful in getting there?
My political answer?
Just do it as that.
Just your opinion.
So
Stop recording.
infrastructure is wild, right? So like, you know, these guys are running agents for stuff and it sounds like they're doing agents with infrastructure. I'm not that, I'm not gonna push the line that hard on that. I like I said, deterministic infrastructure, immutable infrastructure, somebody at the helm that has, you know, heartbeat. In 5 years, you're gonna see the blurring of the lines, I think, of actually what he was just mentioning, like the serverless thing isn't going away. We're shifting to care about your apps and define your apps properly, and don't worry about the Kubernetes stuff, right? The Kubernetes, everybody will know it's running on Kubernetes, but you just won't have to care about it as much. 5 years sounds like a far time. It's not.
It's not.
I don't think AI is going to really influence infrastructure that hard in 5 years. AI in the apps and deploying apps and, you know, configuring apps, it'll definitely do all that stuff. But there's still going to be an SRE job in 5 years. Yeah.
Right, think we need to wrap it up. Who learned something? Yeah, I learned something. Thank you, Ben. That was good. Even not wasted. All right, thank you all for coming. Have some pizza. There's still some left. Next month, I think we are targeting NetApp next month, right?
Yes.
Hopefully NetApp. So we'll come in. They have some very powerful services in Azure. Hope to see you then. Thanks all for coming in.